Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever for our last installment of three-dimensional problems. This is part 3. Let's get to it, shall we? So here we go. All right, we got a pyramid, so we're going to have to draw one of height 40 meters, has a square base with edges 50 meters. Determine the length of these slant edges. Okay, so we need a decent drawing, and if you need a picture of a pyramid, then you need to find one so you can copy it, but they're not too horrible to draw. Okay, particularly square ones. So, first I'm going to draw the front part of the base right here. And remember, it's a square base, and we have to draw it a little askew so we can see it fairly accurately. So I'm going to draw the right side like that, okay? And then these other two edges on the bottom are going to be hidden. So you need to just do a dotted line and just kind of eyeball where you think it's going to be even with over here like this. It doesn't have to be perfect. So there we go. And then we need to, this is the bottom of the pyramid. So this is what people think is the hard part, but what I do is I kind of locate the center of the base there, the square, and just kind of take my pencil straight up, and that's going to be the top of the pyramid. Then I can easily draw the lines or sketch them. I am, of course, using a drawing program, but if you do this, you'll see it comes out pretty nice. And you can do it freehand pretty well. So messed up a little bit there, but I don't care. And then this back edge is going to be dotted, so you would want to dot that with your pencil. You don't want to do a solid line, or your eyes play even more tricks on you. So there's our square pyramid. And it says it has a height of 40. Okay, so the height goes from the vertex, the very top, to the middle of the base. So that would be, I don't know, about right there. So I'm going to draw that in a different color. Go here, make it blue. Let's make it solid. And we'll say that's the height right there. Okay, so that's inside the pyramid. And they're telling me that's 40. So I'll put a 40 there. That doesn't look like a 40, it looks like a 90. So let me redo it. So 40. And then it has edges of 50. So 50 all around each edge. And it wants to know the slant height, or I'm sorry, the length of the slant edges. So I'm going to start labeling these things. So the question is, what is the length of AB? So we got to find AB. Okay, and then I'll call this C right here, and I'm going to call this D. And I'm going to show you why here in just a second. So I'm looking here, and I'm thinking I can use triangle ABC to find side AB. So I'm going to draw this line right here, and then I'm going to pull that triangle out and draw it. Okay, I'm going to kind of rotate it around, then I'll label it so you know what I'm talking about here. Okay, so I'm pulling it out from the middle of the pyramid. Up here is A, down here is C, and over here is B, and since this is straight up and down, I know it's a right angle, and I know this is 40, and I'm looking for X here. I'm going to call this X. I'm looking for the length of AB, so this is my X. Well, I do not know the length of AB, and don't think that it's the length is half of 50, because this bottom is a square. Okay, the bottom of this pyramid is a square. And you can clearly see, I think, that if you draw a diagonal here, it's not equal to 50. It's longer than 50. It has to be. It's the hypotenuse. If I have right, all the squares have right angles. The hypotenuse is longer than the other legs. So half of it can't be 25 if the entire length isn't 50. So don't fall into that trap. So I need what I will label as Y. I need that length y, and then I can use the Pythagorean theorem to find the length of the slant edge. Okay, and then that's this piece right here. Well, a property that we know about squares is that the diagonals of squares are perpendicular. Now I'm not drawing all the diagonals. I didn't go all the way to the other side. But if I did, might be a little easier to see that they form 90-degree angles. So, since they are perpendicular to one another, this angle right here is right. So, triangle, I'm going to sketch it out here. Bam, 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 right here. Okay, so, and I'll label it. Here's C, here's D, here's B, right? And I know this is 50, and I've labeled this as Y, and this is a right angle. Okay, so how in the world am I going to do this? Well, it's a square. So these line segments drawn to the center are the same. So this is Y as well. So I can now write the equation using the Pythagorean theorem. Y squared plus Y squared is equal to 50 squared. How many Y squareds do I have? I got 2 of them. So I have 2Y squared is equal to 50 squared is 2,500. If I divide both sides by 2, Y squared is equal to 1250. And take the square root of both sides, and Y equals the square root of 1250. Bam! So now we are in business because I know that Y equals root 1250. So now I can fairly easily find X, the length of the slant height, which is going to be solved with 40 squared plus root 1250 squared is equal to X squared. So 40 times 40 is 1600. And the square root of 1250 squared is 1250 is equal to X squared. Let's see, 2850. I hope I added that right. 2850 is equal to X squared. And the square root of 2850 is equal to X, which is a perfectly good answer. However, we are talking about length, so we should use our calculator to get an estimate. So I'm going to do control square root 2850, enter, and I get about 53. Let me take a picture of that for us. Back to our calculator, boom, boom. All right, so, oops. So now we got that, okay? And we can say that X is approximately equal to 53.4 meters. All right, that's all there is to it. Hope you enjoyed it, and we will see you on the flip side. I am out! I turn stone.